so that you don't forget the aspects. Okay, I have already told you about these instructions. What is an instruction? Okay, it's nothing but a software. It's a code, a set of code written in the form of English alphabet. It's nothing but instructions. The softwares are nothing but instructions given to the computer, nothing else. Okay, what it does? Ultimately, whatever software you write in high level languages, it boils down to a simple arithmetic operations, logic operations, okay, when it comes to the microprocessor operation. That's why your instructions are basically to do arithmetic logic operations, read the data from and put the data into the memory, okay, and reset and stop. I'm showing you typical instructions which a microprocessor can understand. Okay, I told you this one instruction, equivalent instruction in C language during my last class. Hope you remember that. Okay, this adds content of A and content of B and stores in a stores in a memory location C. Okay, A and B are added and it is stored in a C, or B or C added, stored in A. It all depends on the organization, how your microprocessor is designed. Now see, instruction is just few English letters, right? And you have instruction add here, okay, ADD. Okay, add in English meaning it is addition, right? That means the instructions for microprocessors are all a simple 3-letter or 4-letter instructions which does specific task. For example, add, for addition you say add, for subtraction we have subtract, for multiplication we have mul, like that. These mnemonics, it is called as mnemonics, can be remembered by you, right? When it comes to the assembly level language. Okay, I told you in the beginning itself that we are going level down to microprocessor level, microprocessor stage, and then you are talking to microprocessor its own language, and that language is nothing but your assembly language. And this is one of the example of assembly language. Add A, B, C. What it does is it adds content of B and C and stores it in A. Okay. It can be it adds content of A and B, stores it in C. Okay. It can be any form depending on the microprocessors. Okay. Let us not worry about those things first. Now here we have a mnemonic, or we say assembly instruction, add A comma B comma C, and this is called as assembly language. Okay, but still you're writing the program in assembly language. The microprocessor can understand only this. It can understand just zeros and ones. That means the assembly language need to be converted once again to machine instructions. We call it as a machine language. The one you see here, all zero, the combination of 0 and 1s. This is a 16-bit or 32-bit combinations of zeros and ones represents this instruction add comma B. This is your assembly instruction, and what you see here is the machine instruction. That's what ultimately reaching every microprocessor. Even today, you're writing a program in Python or whatever program you write, when it reaches to microprocessor, it can understand only this machine instruction. Hope all of you understood this, right? Okay. See, your tools does that work, right? You do not worry, right? The whatever compilers which develop, okay, for that operating system, that does the work. For example, you have used Turbo C, right? You must have used Turbo C. So, right, during your recipe, you are going to write a program in simple English, in C language, right? But in the back end, you have the C compiler there. The C compiler will try to convert, okay, this your high level language to assembly language, okay, and then you have something called interpreter, which converts your assembly language to the machine instruction. Right? So there's a conversion happening even today for every programming languages. What you need to remember here is that microprocessor can understand only this instruction, which is called as machine instructions. Right? For writing a program by knowing only machine instruction is not possible, right? Can somebody write a program like this? Combinations of 32 bits, 32 ones and zeros, not possible, right? That's why when the microprocessors are programmed in the beginning, long time back, right? Before, when the calculators are invented, when the microprocessors are invented, long time back, when 8080, some microprocessors are first started, right? The first calculator came in this world, right? Programming was done using assembly instructions only. Have you understood this? Programming is done using assembly instructions only. There are so many assembly instructions are there for a particular microprocessor. Just by using those assembly instructions, program is written. Have you understood this? Okay. In this course also, as a learning, you are going to write your programs using assembly instructions. It's very easy. It's not difficult, right? You need to remember certain mnemonics. That also you need not by heart. It's open book, right? During the examination, you need not by heart all the instructions. Okay, you will be given a sheet where every instructions are given. You just have to use those instructions and write a program. That's all. Right? Put your logic for a particular question, whatever is asked. Right? So hope you understood this. Okay. Now, knowing about these instructions, I'll be going a little fast now. How does microprocessor execute certain instructions? See, you're writing lines of codes, right? I will just write a simple code here. Okay. So simple code, I will write very simple code, move. Okay. I'll just write AH, comma, AL. Okay. You will understand. Okay. Then I will just add. Okay. AH, comma, AL. These are the instruction. Multiply BL. Don't try to understand what exactly AH and all. Let's come back to that. Jump instruction. Okay, these are the instructions. Okay, or whatever you see here, these are the instructions. You will understand when you do it programming. Okay, now these instructions are definitely converted to machine instructions before it is fetched to the microprocessor. Okay, first what it does it, the first work is to write a program. Okay, first you have to just write a program. Okay, then these programs are stored in a memory. Okay, memory, this is the memory. Okay, these programs are stored in the memory. Do you think that this exactly ASCII value of this program is stored in the memory? No. You are going to write the program on an editor, a text editor. Okay, because plain English, right? Okay, but when that program goes very nearer to the microprocessor, what is there near to microprocessor is a memory, a RAM. When that program goes to the RAM, from where microprocessor will fetch instruction, it will be converted into the machine instructions. Have you understood this? Whenever we eat, our body needs protein and all, right? Do you think you eat chicken? Same chicken will be available as a protein to the body? No. It will be digested, certain form converted, and then it will go to your body. It will reach wherever it is required. Like that, a microprocessor will execute an instruction. Only those instructions are available in the form of a machine instruction to the microprocessor. That's so that is stored in the memory. Have you understood this? In due course, you will understand what is the equivalent machine instruction for this. You will be able to do using some table. The conversion you will be able to do it. Okay, but attend all the classes regularly. Definitely you will understand. Okay, now see here. First, what microprocessor will do? Microprocessor will fetch the instruction from the memory. Okay, and it will put it in the register. Okay. We will tell what is register right now. Okay. While executing an instruction, microprocessor does two cycles. One is called as fetch cycle. What is this fetch cycle? The fetch cycle is to fetch an instruction from the memory. Right? It will put it into the a register called instruction register. See, this microprocessor inside it has lot of registers, and you all know what is register, right? Okay. Inside the microprocessor, when you see microprocessor architecture, you will come to know that it consists of various registers. Okay, and you all know what is register, right? 8-bit register, 16-bit register, you all know about it. Okay, so what it does, it takes it from the memory and puts it into the register. First thing it does it, and that is called as fetch cycle. Next one is called execution cycle. See what it does, it receives that instructions which is in the form of a machine code. It decodes it, it does the decoding, it understands what exactly to be done, and then does the execution. Right? Okay, so that cycle is called as execution cycle. It has got two cycles: fetch cycle, execution cycle. What it does in execution cycle, it will execute whatever instruction it is asked for. Fine. So this is about the execution of instructions in the microprocessor. How does microprocessor looks like? You know, what is there inside microprocessor? See, this is what your entire microcomputer system. Okay, this is what your computer is. Okay, see here, this unit, what you see here, this is your microprocessor. Okay, this is your microprocessor, and you are interfacing a ROM, you are interfacing a RAM, and also you are interfacing IO ports. What is this IO ports? IO ports are nothing but it is a place, is a connection to your keyboard, okay, your display, your printer, okay, all those things are called as IO ports, right? And also you can see that there are two buses here. I told you about bus in last class, right? There is one bus called address bus. There is one bus called data bus. Remember here. And these two buses looks different when it comes to the arrow. And you can see address bus has unidirectional arrow, right? Can you see that unidirectional arrow? And data bus has bidirectional arrow. What is the purpose? Can you guess?
Data is taken in and output is given out.
Yes. Data is taken in and out is correct. But address is something different we need to understand. Right. The microprocessor can take the data from a memory, maybe from ROM, maybe from RAM, maybe from IO devices. And it can also write the data back, right? It can take the data, it can write the data. So data bus is bidirectional. But address bus is unidirectional. Why? Why it is unidirectional?
Address bus is the only a signal which is sent into the computer to retrieve something stored at an address.
Exactly. See here. I will tell you what he said is exactly correct. See, this is memory, right? This also memory, right? Everything is stored against some address. Right? See, memory stores lots of data, right? Right? And all this data stored against the address. Unless microprocessor generates a certain address to get the data from ROM and memory or RAM, you cannot get the content of the memory, right? So that means address is only going from microprocessor to the memory, right? Memory does not need any address to be given to the microprocessor. Only microprocessor has to generate, because who wants actually the data from the memory? Who wants the content from the memory? Instruction from the memory? Microprocessor wants it, right? Right? Suppose if I want to go to a particular house, I need an address, right? So I am will be generated. That's why microprocessor will generate only address, right? So address will go separately in address bus, but data will go and come separately in a data bus. That's why address bus is unidirectional, right? Address bus is unidirectional because address bus is separate here, data bus is separate here. Address bus will go from microprocessor to the memory IO. It just generates an address, and from that address data will be going out or in from the microprocessor in a separate bus called as data. That's all. Always remember this. Okay, fine. And this, what you see here, is a microprocessor. It has got different units. One is called as bus interface unit. This is called bus interface unit. Okay, as the name itself indicates that it is an interface, okay, to the microprocessor. Through this, a data will go in and go out. It's like a bus stop, you know. It's like a bus stop in a particular village or particular place. So this unit is called bus interface unit. Then your microprocessor also has a unit called as arithmetic and logic unit. And this arithmetic and logic unit does arithmetic operations and logic operation. And you all know what is your arithmetic operation and the logic operation, right? And see some more things here. You have this control and timing. Okay, see, this entire operations has to be controlled, right? What's the meaning of control? Entire, see, it does some operation, right? Such as clock signals, such as clock, okay, such as read signal, write signal. Different signal has to be given from the microprocessor only, right? Suppose if you want to write the data, it has to do only write, right? Suppose if you want to read the data from the memory, it has to only read, right? Who will control all these things? There is a separate unit required to control this. That is called as control and timing, right? And this entire unit, which is microprocessor unit, is also called as execution unit, UU. UU means execution unit. So this ALU and control and timing is part of our execution unit, and this is bus interface unit. So the entire block diagram you see, we call it as a basic microprocessor system. And this is where we can say this is a computing system. Right? Understood this? Okay, your entire, whatever you say is CPU, central processing unit, consists of all these things. Right? This is the basic model for your central processing unit. Okay, and this can be called by different names. We can also say microprocessor system, right? Microprocessor based system or microcomputer system, right? In any fashionable word or any sentence you can use for it. Okay, that's left thing. Okay. Now let us come back to the core microprocessor. What is there inside the core microprocessor? We are now actually stepping into the microprocessor now, getting into the microprocessor. Let us see what it consists of, right? And I told you most of the time that it is nothing but it is same the digital device, okay? The digital device which you have studied during classes, right? Okay. So let us see what are the contents from your previous semester can be brought in here. Okay. Now see here what it consists of. Your microprocessor basically consists of, okay, registers, very importantly registers. What are registers? Registers are nothing but storing element, right? Right? You all know about registers, right? You must have built 4-bit registers in your digital design, yes or no? There will be shift left, shift right, parallel in, parallel out, right? Ultimately what it does? It stores multiple bits, right? Suppose if you want to store 8 bits, how many D flip-flops you require? Suppose if you want to store 8 bits, 8, okay? You know how does it connected? Suppose if you want to go for parallel in and parallel out shift register, how you do the connections? Tell me. Can you just imagine that connection of registers?
Single input line connected to 4 flip-flops.
Exactly. Right? If it is a parallel in, parallel out, and you also know about universal shift register, right? Right? Universal shift register, where you can give parallel in, you can take parallel out, where you can give signal in, signal out, you can give left in, left out, or right in, left out, everything can be done, right? Ultimately, it is nothing but storing zeros and ones and also shifting that zeros and ones right or left. Have you understood this? You know that is what the registers are, which you have done in your previous semester in digital design. Yes or no?
Yes.
Okay, it has got a direct application to microprocessors even today. Right? It is not something you learn obsolete in digital design. No. It is the fundamental thing you study in digital design. Okay. I'm bringing that here now. Okay, see here. These are nothing but registers. Okay. There is an instruction register and there are many registers. Okay. We call it as general purpose registers. Right. See here. These registers are named as register A, register B, register C, register D, E, F, G, like that. Depending on a particular microprocessor, for example, from Intel, from Motorola, they have different names for that. We are going by Intel microprocessor, which is called an 886 process. But in general, the registers are named by alphabets, sometimes by its name. So what you need to understand is that your microprocessor consists of registers, a set of registers, and these registers are the same register which you studied in your digital design, nothing else. Next, it consists of arithmetic and logic unit. What is arithmetic and logic unit? Come on. Adder, subtractor, right? What is logic units? AND operation, XOR operation, OR operations. You all know about the corresponding circuits, right? Yes or no? Right? You know what is adder, you know what is full adder, you know what is 4-bit adder, you know what is 8-bit adder, you know what is subtractor, right? You know logic operations and OR and NOT operations. You know circuit, right? You can just imagine what are the circuits for that, right? The same thing here. And these are available in the form of multiple bits. Right. Suppose if I say this processor, this microprocessor is a 16-bit microprocessor, right? Then size of the register is 16-bit here. All the registers are 16-bit. And your ALU also can do 16-bit addition, 16-bit OR operation, 16-bit XOR operation, 16-bit subtraction, everything is. Have you understood this? Okay. So this, the size of this, okay, these registers, arithmetic, logic unit, instructions, everything depends on either 16-bit or 32-bit or 64-bit. Right? At present, the Intel microprocessors are producing 64-bit microprocessors. Right? The maximum modern microprocessor, you are 64-bit in that. Then you can ask, sir, why didn't they go for 128-bit? There was no requirement of 128-bit. There is a requirement of multiple cores, right? For multimedia operations. So these microprocessors are developed based on the need. Okay, 64-bit, they stopped. They did not go for 128-bit, but all modern processors have multi-cores, multiple 64-bit ALUs in that. Have you understood? That's called multi-core. So that your instructions can be executed in parallel. That's very important because nowadays your data size is huge, right? You need to do deep learning. Your data is huge now because you're going to feed in lots of data, right? Your data number is more, data size is not big, right? Okay. So 64-bit suffices for a microprocessor. That's why none of the companies have gone more than 64-bit, but they are all producing multi-cores, different cores in a single microprocessor. What we are going to study is single core microprocessor. One core is, if we study one core is enough. Okay. All modern microprocessors having multiple cores in a single microprocessor. Okay. Those things you are going to study in computer architecture, which is going to be in your next semester. Fine. Okay. So have you understood this? See, as I told you, this has got a registers, you got a ALU, and here you have got something called as program address generator. I told you the address has to be generated from the microprocessor. Microprocessor will generate the address. Okay. See, suppose microprocessor. I'm just try to visualize the situation that this is a memory. Okay. This is your memory. Fine. This is a memory. This is the memory. Okay. This is the memory. I told you that suppose this is the 8-bit memory. 8-bit memory means each location you can save how many bits? 8 bits. I already told you about this in my previous class. Okay. Now this is address 0000. Okay. 0. Suppose if this is 1 MB memory, you will have a 20-bit address. Okay. Which will be represented by 4 hexadecimal digits. Okay. I'll tell you about all these things. And this next location will be 0001. Next location will be 0002, like that. You have last location will be FF in hexadecimal. Okay. Now, all these, the content of all these things are nothing but instructions or data. Right. So, microprocessor needs an instruction, right? What to do? It will fetch that instruction from the memory here. Okay. To fetch that instruction, it requires an address, right? It requires an address. Instruction may be anywhere in this memory. But microprocessor needs an instruction, it generates an address, and that address is generated from this program address generator. So microprocessor will now generate an address, and that address will be going to the memory through which bus? Address bus, because address is only going from microprocessor to memory, right? But data will be bidirectional, right? So, and whatever data which is available in this, that will be going by separate bus called as data bus. Address is going separately, separate bus. Data is going to separate bus. Okay. First, microprocessor will generate the address, and that there is something called address decoding, and that address decoder will get the content of in that address. That content may be the instruction to the microprocessor. That will be loaded into the data bus because that's the content, right? And that will come to the microprocessor. Have you understood this? Okay. So now this is what actually it will generate the address, and to data bus instruction will come, and that instruction will go and sit in the instruction register. See, you have address generator, and this address generator is connected to the memory, right? And this whatever the instruction which is the machine code which is stored in this memory will be loaded to the instruction register through which bus? Data bus. Data bus. Right, and that will be decoded by this microprocessor, and it does the operation, and it can store the data either in this register or in the memory. This is what the operation of a microprocessor. Entire semester we are going to see one by one how does it work. What I said is just a trailer of entire syllabus where you study how microprocessor generates an address, how does it gets the instruction, and how it executes inside this microprocessor. Okay, fine. Okay, just try to understand only this much is enough. Okay, it fetches the instruction, it decodes the instruction, it fetches the operand, and then it executes. Right? See, suppose my instruction is say add, okay, A, B, C. Okay, let us consider that my instruction is add A, B, C. Assume that, okay, your operands are B and C, okay, and result is stored in the A. Right? Okay. Now what microprocessor first does? First it fetches the instruction. The instruction corresponding to this add ABC is stored in the memory. Okay, it's stored in the memory. So first microprocessor generates its address where it is stored. Instruction is now taken to the instruction register and it decodes it. That's what I said, instruction decode. After instruction decode, it needs operand, right? Where the operands are? See, B and C. Suppose B and C are the operands and A is the result. Okay, that means in A you have one of the operand, say 16, example, and B you have another operand, hexadecimal, 16H and 30H. So microprocessor will take one operand from here, another operand from here. And where does it stores the result? Sorry, B and C here, not here. Okay, this is 16 here, 30H here. So after addition, where it stores while execution, that is last stage is execution. After execution, where the result will be stored? It will be stored in the A register. I have understood this. This is basic thing you need to understand now. We are going quite deep into this. Okay, this ABC need not be only a register; it can be memory. Okay, when we consider a typical microprocessor 8086, Intel 8086, there we are going to see all a particular microprocessor and we learn all those things. Fine. Okay. So this is about microprocessor operation. Then store. I told you it is going to store the result. Now, as I told you, how do you decide size of the microprocessor? Okay. Suppose a microprocessor can be called as 32-bit, 16-bit or 8-bit. What decides a microprocessor is 16-bit, 32-bit or 64-bit? I told you size of the data bus, size of the data bus, size of the register, size of the ALU. Okay, suppose if size of the ALU is 16-bit, that microprocessor is called as 16-bit microprocessor. Suppose data bus is 32-bit and that microprocessor is called as 32-bit. Mixture is not possible. A microprocessor cannot have a 16-bit ALU and 32-bit data bus. Why? Not required, right? Right. So all these sizes can tell you what is the microprocessor bit size is. Okay. These microprocessors, how do you study these microprocessors? Okay. These microprocessors can be studied in different domains. Okay. See, every microprocessor has got its own architecture, right? Before this, you have seen one architecture, right, of a microprocessor. It is very generic architecture. Okay. And every company who manufactures this microprocessor have their own architecture. Okay, right? Now, how do we see that architecture? Okay. What we require to know about architecture? Right? Fine. See, what I have shown you in the previous slide is just a small information, very abstract information which shows the registers, which shows the ALU, right? It shows only registers and ALU. That's all, no? Right? But is it, exact architecture? Is the only way you look at architecture of a microprocessor? No. What you saw is just a block diagram, right? An architecture of a microprocessor can be seen in different domains, different views. Okay, one is instruction set architecture. Another one is called microarchitecture. Another one is called physical realization. What is that? I will tell you. Instruction set architecture. See, you are a programmer. You are just a programmer for a microprocessor. Right? As a programmer, you need to know only about registers and ALU and other things. So, do you need that internal circuit? Do you need to know that for that register, which flip-flop is used? Do you need that flip-flop level understanding to do programming? Not required, right? Do you require it? No. The previous slide which I shown you, I have just made some, table. And I told you it is actually it's of registers. Right? Hope you remember my previous slide, right? How did I show you the registers? A table. I said A, B, C, D. All these registers. Okay. That is called as instruction set architecture. As a programmer, you need to remember only that. Enough. Right? Have understood? Now, what is microarchitecture? If I show those tables with a proper D flip-flop and connections, that is called as microarchitecture. Have you understood now? Right? Now, let us go one step below, which is called as physical realization. Suppose if I show every D flip-flops, as a combination of OR gate, right? That is called microarchitecture. So that's why I told you this microprocessor architecture can be viewed in different domains. As a programmer, you need to know only registers enough. It is none of your business which D flip-flop you use there. That connection is not required at all for you. Have you understood this? Okay. When you buy a car, okay, you need to, are you going to study exactly which engine, in engine which screw is used, which bolt is used? Are you going to see that? No. You are just driver for that particular car, right? What you need to know? Certain things. What is the mileage? How does it look? How the front look? But you will not see what is there inside the engine, which brake shoes are used. You don't see, right? Right? In the same way, as a programmer of that microprocessor, you need to know only instruction set architecture. That is, you need to know about execution model, processor registers, address and data formats. That's enough for you. Suppose if you are a hardware engineer, you are actually designing a microprocessor, right? That time you need this microarchitecture. The same registers which I have shown you, in that case, you should study in D flip-flop level, like you did last semester. Have you understood this? That is microarchitecture. Now, same D flip-flop, same registers which is built using D flip-flop, if you draw in terms of gates, once again, that is the physical realization. Have you understood this? Okay? I'll just simply write, see, suppose if I say, this is an 8-bit register, I say A, okay? This is a register, right? I say 8-bit register. This is enough if you are only programming microprocessor. Suppose if you are a hardware design engineer, then you should write the entire diagram. What is that? D, right? This is Q, D, Q, D, Q, like that. This is also register, but you have shown its microarchitecture. That is this. Now, you all know how do you reach to D flip-flop? NAND implementation or implementation, yes or no? Come on. Right? That is your physical realization. That means a processor can be seen in the domain, three views. One is only for a programmer, as an actual designer, hardware designer, and still in the IC chip, when you do integrated circuit, you don't see this. Right? Hope all of you understand about this. Okay? All these things are only theory. We just have to remember. So instructions, I think now the time over, I think I may need one more class for this. Okay, so I'll just come back to this, your syllabus, okay? Quickly, what are you going to study in this? Okay? You're not going to see the microarchitecture, don't worry. Right? Okay? Visual design is already done. Okay, we're not going to see microarchitecture here. Okay? What we're going to see is instruction set architecture, and we're going to see about the programmer's model. We're going to simply see little processor architecture. Very important thing is this programming. Okay, assembly programming. How do you program this microprocessor? Okay, then we see little about timing diagram, and then we just see how do you interface, okay, interface memory to the microprocessor. I told you that microprocessor and memory are like friends. Without one cannot live without each other, right? Right? A microprocessor means there is always a memory over there, right? But how do you interface that memory? How does address generated by microprocessor is decoded? How do you design that address decoder? Right? That is actually called as memory interface. And we are going to study that memory interface. Okay, this is the syllabus. Okay, and then we are going to connect I/O. How do I connect an I/O device? How can I connect a motor, stepper motor? How can I connect a keyboard? How can I connect a display? That's going to be the last chapter for me. Fine. These are the syllabus, and maybe evaluation component. You are very much interested. There will be midsem exam. Okay, and there will be compre exam. 40%, 25%. There's a lab. Lab is 25% evaluation. Never miss the lab. You just have to do some program, execute and go. Right. See, you have 15% internal evaluation, and lab compre is 10%. Okay. You need not buy the instructions. Instructions are given to you. You just have to use the instruction and do the program, whatever question asked to you. That's all. Right? And you have a quiz which is closed book. Okay, the date is given here. I think these are all quite clear for you. I think we will continue with this slide for the next class. I'm supposed to complete this slide today. I don't know, I have given a little more instructions to you. Okay, so let us see. We are going to see in brief what are different types of processors available. Something called as RISC processor and CISC processor. That's very important. I'll be covering it in the next class. Okay, so do come to understand. Hope all of you understood what is done in this class. Okay, I told you about different architectures, right? And I told you how microprocessor is decoding. Okay, so I'm going to share this with you all. If at all you're interested, you can just go.